Not every function can be written using only one equation. Some functions have different forms depending on the value of x. When you graph these functions, they look like they're split up into different pieces. Such functions are called piecewise functions. This is the notation for a piecewise function, f of x, and we use this curly brace, so you might only have two pieces or more. These would be the individual equations we're used to seeing, and next to them we'll list their respective domain, which interval of x each piece is defined on. There are a few things we might have to worry about with piecewise functions since their graphs look a little scattered sometimes. We have this idea of continuity. For you and me, a function is continuous if we could draw its graph left to right without picking up our pencil. Anytime we'd have to pick up our pencil to make a break or a gap or a jump in our function, we're going to call that a discontinuity. This is a very common occurrence with piecewise functions. Let's look at a quick example. Here we have a graph of a function who is piecewise. Notice this picture splits up into three different parts. You'll also probably notice that there's this jump here at x equals 0. The first piece sort of hops up to the second piece, and then there's another gap here, another discontinuity as it's called, over the entire interval x equals 2 to 3. The function just isn't even defined there, and it sort of skips from one function to the next. Thus, we officially have these two discontinuities, namely at that first jump, x equals 0, and over the entire interval 2 to 3. Remember, our function wasn't even defined over that gap. So we can list the domain of our function here. Our function only stretches as far left as -5 in the x direction, as far right as +10, and we need to exclude those discontinuities. So we'll include that interval -5 to 0, also 0 to 2, and then 3 to 10. We're leaving out the interval 2 to 3 because our function wasn't defined there. And notice we're using these closed brackets because the endpoints are included. Our function does attain those values at the endpoints. Now, what do you suppose these functions actually are? Well, this first one on the left in blue is a straight line. It's a straight line through the origin. This is the equation y equals x. What about this one in green in the middle? It looks awfully quadratic. In fact, it's the function x squared raised up 1 unit. If you think back to your vertical translations, this would be x squared plus 1. And lastly, on the right, horizontal lines look like y equals a number. In this case, it's a value of 5. This is the equation y equals 5. These are our three pieces, and we'll list them using that curly brace notation on their respective domains. Thus, here we have it. That first equation, y equals x, that was from -5 to 0. That's its domain. Then we had the middle function, that quadratic x squared plus 1. That was only between 0 and 2. Then we hopped over to that horizontal line 5. It was defined from 3 to 10. So we can list all of these using that piece notation. We just list the three equations, x, x squared plus 1, and 5. Next to it, we list the domain, or we list the specific interval. Piecewise functions can be a little bit confusing at first, but I think you'll get it down with a little bit of practice.